In Learning Target 4, we're going to talk about graphing exponential and logarithmic functions. We've already looked a little bit in algebra about the graph of an exponential function, but we're going to review that a little bit. And then we're going to talk about logarithmic functions and how to graph those. And then also you're going to need to retrieve your prior knowledge about transformations, because all of those will apply the same as they do to these. So you'll have the parent functions, and then all the transformations will apply in the same way, and you'll need to be able to know how that works and to be able to figure out how a graph might be drawn based on its parent function and then the transformations that are applied to it. So one new vocabulary word is the asymptote. So an asymptote is a line, a straight line, that a function approaches but never reaches. Okay, so this has to do with the limit. So basically it's when a function is exponential. Usually there is a certain place where it approaches a certain value but never actually reaches that value. And so that's what an asymptote is that invisible line that you can draw in there. So for example, when we are talking about exponential decay, when it's maybe translated up a certain amount, there might have been a certain line where the function goes down and begins to approach its limit. The line y equals, let's say 2 in there, that would be called your asymptote, because that is the line that the function approaches but never reaches. So exponential functions can come in two forms we've talked about already. They can come in the form y equals ab to the x, or in point ratio form, which would be y equals y1 times b to the x minus x1 power. Okay, so exponential function is really the only thing you need to write down right now, is that an exponential function usually has a horizontal asymptote. Okay, and then a logarithmic function is the inverse of an exponential function. So we kind of have already talked about that a little bit. They're inverses of each other. These will have a vertical asymptote, and we're going to use the concept of inverse functions to help us graph logarithmic functions. So the first one I'm going to graph is an exponential function, y equals 2 to the x, and my advice to you is to make a table of values to help you graph this type of a function. So I would just plug in some numbers. So let's plug in a couple values of x. So 2 to the negative 2 power is 1/4, or 0.25. 2 to the negative 1 power is 1/2. 2 to the 0 power is 1. 2 to the first is 2. 2 squared is 4. Maybe we can do one more. I don't know if this one will fit. 2 to the third is 8. So we can graph a couple of these points. So let's see. Here's 3, 8. Here's 2, 4. Here's 1, 2. 0, 1. Negative 1.5. Negative 2.25, so on. Okay, so I can actually see that actually in this one, it's going to get bigger and bigger exponentially on the side. So there's not going to be no asymptote vertically here, because this is an exponential function. I'm going to be looking for a horizontal asymptote, and in this case it's the x-axis, because we've got values here getting increasingly smaller, but they will never actually reach 0. They'll just get closer and closer to 0. So here I've got the exponential function y equals 2 to the x graphed. So this one actually, if I ask you to define the asymptote, the x-axis is the equation y equals 0. So graphing the line y equals 0, that's a horizontal line here where y is 0. That's the asymptote. Okay, So for example, I wanted to go over to decimals for you. So if I was to graph y equals 2 to the x, here it is, just like the one that I showed. Now I talked about how transformations, so for example, if I have y equals 2 to the x plus 4, it's going to be shifted up 4, and so you'd use that to help you, and then your asymptote would now be at x equals 4. So I could graph that line, y equals 4. There's your asymptote right there, okay? You got your parent function, your translated function, and your asymptote, okay? So next we're going to graph the log of x, and notice there's no base. So what I know about this one is that it has base of 10. Okay, and so what you're going to do is you're going to think about this function is y equals the log base 10 of x. So what that means is 10 to the y power equals x. And so to be able to graph this, we're going to actually think about the inverse of this function, which is y equals 10 to the x. Notice the x and the y are just flipped. And so what I know here is that y equals log 10 of x and y equals 10 to the x. If this is the function I'm trying to graph, then y equals 10 to the x is the inverse of what I'm trying to graph. And so I'm going to make a table of values for y equals 10 to the x power. And then I'm going to make a table of values for this one by swapping all x and y values. So this one, y equals 10 to the x. I'm just going to do my typical here, -2 to +2. So 10 to the -2 power is 1/100th. 10 to the -1 power is 1/10th. 10 to the 0 power is 1. 10 to the 1 power is 10. 10 squared, or to the second power, is 100. So obviously, really only going to be able to graph a couple points here. So then, if I'm looking at graphing y equals log base 10 of x, I can just take each coordinate that I'm going to use and I can flip it around. So when x is 0.1, y is -1. I took this point right here and I swapped its coordinates, x and y, to take and go back and find my original function. So if I find the log base 10 of 0.1, I'll get -1 out for y. And then I'm going to graph 1, 0 and 10, 1. Okay, so I'm going to graph each of these points here. So 10, 1, 10, 1, 1, 0, 0.1, -1. So here it is. And actually what's going to happen here is, it's going to approach, it's going to get larger and larger on the left-hand side here, and it's going to approach a vertical asymptote this time, which is the y-axis. So that's the equation x equals 0. Okay. So something I want to show you on Desmos is to remind you of how inverse functions look on a graph. So remember that the line y equals x splits our plane exactly in half diagonally down the middle, and any function and its inverse will be reflected across this line. So if I graph y equals 10 to the x, and then y equals log of x, which is automatically base 10 if I don't type one, which I said were inverses of each other, you can see from this graph here that graphing those two, flipping the x and y, reflects them over that y equals x. So that's how you can kind of get a visual of what those inverses look like. So that's how I graphed log base 10 of x. So, and then, like I said, anytime that you want to actually graph something that's a variation of this, you just might apply a translation. So, for example, you could graph this with 3 added to it, and it would just go up 3. Or x minus 2, that would shift it over to the right 2. And so then you'd have a different asymptote, and it would be shifted over. And you can apply stretches, shrinks, reflections, all of those kinds of things to these functions as well. So, your job, because of that, before class, is just to look at each of these general descriptions without knowing what the function is, just adding something outside the function, subtracting something inside with x, changing the x to its opposite. I just want you to describe what that transformation would be, just kind of as a review and to get us going before class.